Hello, everyone. Let's begin. Welcome to today's webinar. Is your data ready for AI? Common pitfalls and practical solutions. I'm your host, Mike Teeling. As more enterprises adopt machine learning, generative AI, and now agentic AI, there's one challenge that consistently rises to the surface: data readiness. Can we bring up the first slide, please? So Gartner predicts that by 2026, 60% of initiatives that lack AI-ready data will be abandoned. One thing is becoming clear: your AI is only going to be as powerful and effective as the data that it runs on. That makes today's conversation critical. With me is Ratnesh Parahar. He's principal architect at Talentica Software. Ratnesh has led enterprise data builds across machine learning, GenAI, and RAG. He'll share some proven strategies and real-world use cases to help you ensure that your data is not just AI ready, but future-proof. Welcome, Ratnesh.
Yeah. Hello, everyone. My name is Ratnesh, and I'm principal architect here in Talentica Software. My primary goal is to build scalable systems, and primarily both for enterprises and the startups. And in last 5 or 6 years, I have been deeply involved in data projects, data lakes, data warehouses, big data technologies. And recently, in last 2 to 3 years, I have been part of multiple projects where AI enabling was required in all these data pipelines. So I learned a lot of things. So today I will share my experiences with you.
Excellent, thank you. Let's take a look at what we're going to cover today. So over the next 30 minutes, we'll cover why data readiness is no longer optional in the Gen AI era, how data requirements are shifting, and what steps enterprises like yours can take to stay ahead. So before we get started, there are a few housekeeping items that we need to cover. During the session today, you'll see a few pop-up polls. Participation is, of course, optional, but we really like to get your input. So please respond and lend your opinion to today's topic. Second, be sure to stick around until the end, because we're going to have a live Q&A session where you can ask your own question of our AI expert. Finally, today's webcast will be made available through you with an email follow-up after today's session. It'll have an on-demand playback link that will be sent to you, and the results of our poll questions will be shared as well. So please look for that after today's session. All right, with that out of the way, let's dive in. You can take it away, Ratnesh.
Yeah, thank you, Mike. So as I said earlier, I will share my experiences. I have been involved in many AI projects where the data pipeline has been involved, and many of them, majority of them get failed. And one of the primary reason is the quality of the data. And this is essentially something make or break it. But normally it doesn't happen that way. People start building their RAG pipelines, they start building chatbots, start building uh, similarities, start doing chunkings, and they just want to collect the data no matter how is it possible. So they start to connect to LTPs, their S3s, uh, whatever the data is available, they start building it up. And what happened the moment they start testing or put on UAT and the production, they start to see that a lot of hallucination, false positive start to appear. And the primary reason, in my experiences, is the uh, first of all, the data is poor. There is no governing body which is controlling the data. Data is too much scattered and too much sliced, and these are the pitfalls I think we will talk about in the next couple of slides. So very quickly, this is almost everyone aware that after the deep learning, the majority of LLMs got succeed, and now a lot of tools around the data and all the frameworks are popping up. And essentially, the way, at least my personal opinion is, if those tools and frameworks got succeed, there will be a boom And if they don't get succeed, I think what essentially will happen will be another .com boom. But we should be prepared as a data engineers or data architects is we need to make sure that we follow these trends, we follow these tools, we keep on building these systems, start learning things. Uh, so now, when I was constructing my uh, whole experiences with AI and the data pipelines, I kind of converted into the 7 pointers. So this is the 7 pointer checklist. Whether your system or your data warehouse, your data pipeline is ready for the AI or not. So one of the thing I like to point it out how to build a system which is making first time right, or you build a system which is by design is correct. And these are the 7 points which you can check for yourself. One of the primary thing is like unification, whether your data is centralized, people can access with a single connection. Whether you can, second part is whether you can discover it without accessing the actual data, so that you don't need to do and build your own schemas. Whether the quality and reliability checkpoint has been implemented in the place, uh, whether the real-time uh, implementation can be done, can chatbots access the data in real time. Trustworthiness means is data uh, is complete, is trustworthy, can whatever the LLM responses come out of it are can be trusted, because already LLMs are non-deterministic. They give uh, hallucinations and lot of things has to be built on the top of it. And again, if your data is not trustworthiness, then it's a more problematic. Scalability, you need to this is something I learned personally, that you need to make sure that whenever you are building RAG or LLMs, these are premier subscriptions. And if you are building solution on top of it, essentially you are building a premium solution. And you need to check with your user whether they will pay premium for your things or not. So in order to, but if it is not the case and you want to build a normal enterprise application, not the premium one, then a couple of things has to be implemented, which is related to the cost effectiveness. Last part is the context. Is your data built in a fashion that it can be used as a context, whether it's a user context, tenant context. These are the 7 checklists. We will deep dive into all these 7 points.
Oh, that's great. It's going to be good to hear all 7 of those and cover those with examples. So thank you. So now, guys, let's take a moment to hear where your organization stands on data ready AI. So our first question is, where are you and your organization in your AI journey today? Please take a minute to register your response. And question 2 has to do with your data infrastructure. So does your product currently use a data pipeline or a data warehouse or both or neither? Please let us know what you think. And so we'll take a moment here to pause and wait for some responses to come in. Okay, great. Thank you for everyone who responded. We really appreciate hearing your input. So these quick polls give us kind of an idea of where you guys as an audience are in your AI journey and how you're approaching your data infrastructure. So now it's ready, time to move ahead and dive into our first case study. So right now, back to you.
Yeah, thanks, Mike. So here is the first case study. This is the case study of the Series B e-commerce. And since it's a Series B, you can assume that there is a success story and they have pretty much a lot of data is collected. And what they want to build is they want to build a next gen AI support chat. And this support chat is all about whenever some customer contact with a support person using a chat, essentially the support person can reply through the recommended responses. So the chat will happen, and the support person will see a lot of recommended uh, responses uh, at the end of each iteration. Okay, so it is not automated, but it will build it will be built for the operational efficiency, so that and the accuracy. So one of the example is Pixel. Let's say uh, some person bought a TV, but there are a couple of pixels not working well. Okay, so he opened the customer support, and customer support responded that customer support saw that prompt, and he also saw the recommended responses. One of the recommended response was go into the setting and make some changes. Okay. So now this is a very smooth from the user experience perspective, because he don't need to go and wait for 24 hours and all those things. So now this is the case we will going to talk about. And the second part is essentially is uh, you need to review all the chats and conversation and providing some level of scoring. So this is the case study we are going to cover. Now let's talk about what is their system. So this is their architecture. So this is a very simple application layer where multiple apps running as pods. It's a primarily SaaS application, and it has both a structured and semi-structured data. So unstructured data is primarily voice transcripts with the customers. Semi-structured data is like the chat discussions. Okay. And one of the key thing here is we need to remember that essentially in order to build this feature, I'm just calling it as a feature. In order to build this feature, you need all the data. You need inventory data, you need product data, you need payment history, user transactions, and you also need vendor reputations, all the comments, reviews, everything, so that you can build the proper chat system. So now going with the architecture, this is they have OLTP, then their streaming logs are available in the data store, and they have already ready-made uh, built data warehouse and the data lake as well. And now we will discuss what they essentially can they build this feature properly, production grade, production ready feature using this data warehouse, streaming logs, and the data lake. Okay. So, as I said earlier, there will be challenges, and now we'll talk about these challenges. One of the primary challenge will come up since there is no cataloging defined. The moment you customer put some input into the chat box, it come to the chat person, customer support person, and now that it will hit an API, and that API will go and collect the data. It will do the summarization, and then it will hit the LLM, and then it will build the responses. Okay, and now where it will hit. Okay, so if my backend developer asks where I will hit it, what kind of data I will get, it is very hard as far as data warehouses and data lakes are concerned. So if you have traditional data warehouse running for 10 years, it is very hard until unless you have proper catalog defined where all the data is properly cataloged, and system can access those catalogs so that those prompt and responses can be structured properly. The same goes with the lineage information. There might be the redundant data would be available. The ownership access control is not properly defined. There is a governance gap. Like if one of the example I took for this is let's say uh, you are calculating multiple values and they have different meanings, then normally AI will get confused and it will tend to do the hallucination. So essentially, what you need to do is you need to implement some quality checks, and these will be ad hocs. So these are not built as a design. These might have been built as a explicit implementation in order to handle some values. Okay, so missing values, outlier, duplicate, they might be handled. And one of the major thing which might lead to rethink about this whole design is the context. So user context is there, there is a tenant context is there is a product context is there. Now inside the product, you need to figure out the vendor context as well, because the vendor and then there is a review context. So you need to fetch all the reviews information. So if the system is not built from this context perspective, then again it will be go to biases and hallucinations. So now we will talk about another aspect is if we have to handle, and we need to make sure that we properly do unification. and the making sure the data is discoverable, what changes we can essentially implement. So these will remain same. The only thing we will change is we will start using the data lake, uh, and on the top of it, you can essentially build your warehouse on the top of it. Raw and curated business data layers will be there. And what has been changed here primarily? So the word we are looking for is the implicit. So the problem which we were talking about earlier in the modern data lake, those things, majority of things are handled implicitly. So by the nature, for one of the example is the immutability. All the layers in the data lake is immutable. So there is no chance of data duplication, and though there is no chance of making sure your data is corrupted. Okay, so this is one of the example. And similarly, quality checks are implicit. And the way the whole design works is you have to go by the design. So if you're using dbt tools like dbts, essentially you need to build your catalogs, you need to define properly audits, your p2 level masking. And once this part is done, the quality of embedding and the quality of the semantic layer and the golden standard data, what we call as, will be way better than your other things. So one of the thing can be done is you can start working with your existing data warehouses and lead to a lot of false positive and hallucination. Another thing, you can make some changes, convert into a proper data lake, and once those things are done, maybe you can then you can work on your embedding in the semantic layer instead of connecting to OLTPs or existing data warehouses directly and creating embedding top of it. At the end, it's a data, but the level of the quality of data, the cataloging, the reliability of the data you will get on the top of Delta Lake is far superior than your OLTPs and data warehouses. So this is the part where the unification and discover will help. Third part is the quality. So first, the way it will happen in the Delta Lake itself is, first is the ingestion. So you need to in the ingestion itself, you will do the schema curation, formation, and the deduplication. And once the next part itself is the storage. So data integrity, as I said earlier, is a immutable data. So you can properly build audits. You can make sure data integrity is maintained. Again, the relevancy relationships can be maintained. You can implement your own constraints here. Then commonness come into the picture where you maintain your data log, which is all about maintaining proper data dictionary, making sure that data is by far completed, there is a proper ownership defined, and the compliance has been maintained. Uh, Last part is the semantic checks. So this is the layer I will talk about in another case study. But for now, these are the four important points which we have to remember, that this can be used primarily for generating embeddings, and you need to make sure that these embedding are generated on the top of it, not from the any other source of data. It has to be consistent. It need to make sure that chunking can be accurately done, because these four items are crucial for AI success. So if your context can be fetched in real time, if your chunking can be done accurately because your data is proper cataloged and clean, if it is consistent and its embeddings are accurate. So if these 4 points are done, I think majority of your uh, false positives hallucination will go away. Still, you need to work on it, but most of the things will get done.
Wow, that's great. Thank you so much for that really in-depth example. It was great. Okay, folks, it's time for our next poll question. So the question here is, what is your biggest barrier to making your data AI ready? So we'd love to hear from you. Please take a moment to respond. You'll see some choices up here. While we're doing that, I also wanted to remind folks to get their questions in. There's no reason to wait. So that Q&A button at the bottom there, you can click that and add your questions at any time, and we'll get to them here at the end. But let's hear your answer to this. I think we've had enough time there. All right, excellent. Thank you so much for weighing in. So all of these choices highlight some of the real world challenges that organizations like yours face when they're building AI-ready data foundations for their projects. So it's always valuable to see how different groups prioritize these hurdles. So, all right, awesome. Okay, let's get back to the good stuff. Back to you, right, Nash. Thank you.
Yeah. Okay. So now we will discuss another case study. So this case study is all about a payment aggregator running their business for last 20 years. They are aggregating 1 million transactions per day. And what essentially they want to build is they want to use GenAI for doing the real-time fraud detection and the chargeback management. So if you're not aware with the chargeback nowadays in US and Europe, what customers are doing is they bought the product, they received the delivery, and after that they complain to the bank that they didn't make that payment, and banks are obliged to do the refund in 24 hours until unless someone's do a objections to that transactions. Okay. And this is where the merchants are losing money, around 15 to 20% for SMEs. So essentially, this system wants to implement. They have the fraud system detection, but it's not real time, and they want to use GenAI now, and they also want to handle the chargeback. So it's a large scale system. So we will look into their current architecture. So their current architecture, they have K8 based APIs. Currently, they have built the Spark Batch ETL. So and the database is MySQL. Uh, they have already have a data warehouse in the Redshift, and they already using Postgres as their primary OLTPs. Redis as a cache, and Elasticsearch is there for providing the search and payment tracing. Okay, so now let's think about if we have to use the GenAI for such a system where the traditional Spark batches ETL has been built, Redshift data warehouse has been used. How easy that can be done? So let's go one by one. So let's talk about the real-time fraud detection. So real-time fraud detection, if we have to do, so one of the use case I will take what we call as a organized crime. So you might see a lot of $1, hundred instance of $1 charges, and these are all frauds. Okay, so looking into the timestamp, the amount, the person, geography, and demography data, you can essentially tell, okay, this is some kind of fraud is going on. Looking into all the payment data, right? So now, if that user make another transaction, essentially the system need to bring this concept into the picture that yes, this person has already made $1 payments in last 3 or 4 times in a same times from the same demography for the same product. Okay, so this is a very simple algorithm and nothing fancy about it. But using the GenAI, it will make it smooth. Because you don't know how many permutation combination are going to happen. So, looking into the current system is typically you can see the challenges straightforward. One of the things, there is no way to do it real time because you still need to for this particular event you still need to fetch the data, then batches of the ETL will run, then you still need to access the Redshift data. So you will lose the time at the end, and it might happen after 3 or 4 hours, and then you might, or maybe weeks, 3 or 4 weeks later, and this is what was happening with them. So one of the person came to us and say, boss, these are the frauds happening for the last 6 7 months, and then we calculated the amount is more than 500K for only for that particular merchant. Okay, so what we did at that time is we started building a different architecture around it. Very first thing, we instead of for accessing the data ingestion, we converted into Debezium and CDC. So essentially, it will capture all the data from all the OLTPs without putting any overhead on the their existing system. Okay, all the data will be captured in the Kafka. So it will give you one another layer of immutability. All the CDC data will be captured in the Kafka. Now, after that, we build the Delta Lake on the top of it. And now, instead of building the heavyweight ETLs, we converted into the Spark streaming. Again, uh, we use Databricks as a primary vendor here. And another thing which we did for the context management is the Unity catalog. So we work heavily on the Unity catalog. We look into their orders, payments, their payment gateway responses. We categorize them properly, and that enable them to build this fraud detection system. And second part for the chargeback happened implicitly, automatically. We didn't build for chargeback, but it happened because of the Delta Lake's immutability. The idea was to, once something has happened, a customer has made a false claim. Essentially, the system need to collect all the evidence, build a PDF file with all the pictures, all the transaction data, and very quickly using the automated API, make a call to the bank system and submit the evidences. And now the bank will halt the transaction. So this is something it will take us like 8 to 9 months in order to come to this architecture. We didn't change a lot of things. They are still using their data warehouses. They are still using Elasticsearch. But for AI, the way to go is another Delta Lake, and using the Databricks and using the Unity catalog, we can go to tools right now for at least for the AI. Now we will talk about the trust. So this is another extended version of real time. So one of the another thing you can do is you can use delta live tables in the same structure which we did in that system as well. Now essentially what it will allow you to do three things. You can use AI and BI tool all together in the same data set within a second and minutes latency, and you don't need to define any split architecture. So in the same platform you can also do the batch processing, and streaming is there. So all these kind of things like fraud detection, personalization, chatbots can be done in the real time. Now I will talk about the trustworthiness. So as I said earlier, I will talk about the semantic layer as well. So one Fortune 500 lender wants to re-architect their 15-year-old data warehouse. So they had one data warehouse which was 15-year-old, but they clearly identified that it can't be used for AI. And one of the major problem is that they have tons and thousands of KPIs and insights, and there was very hard custom business logics has been written inside it. So there were procedures who were doing all these KPIs and insights. So that legacy was there, and essentially this led them to believe that it can't be used as a AI, which on that hypothesis they were correct. So their current architecture was .NET 6 apps on the Azure. They had the SQL-based ETLs, so you can assume what kind of system they might have been built. SQL Server data warehouse, which is a very powerful data warehouse in its own. They are using SQL Server itself as an OLTP. And just like S3, they are using blob storage on Azure to store their raw files. So this is very straightforward architecture. They were using both Snowflake and the star schema on their data warehouse. So now you can assume this they have the hierarchy of schemas has been handled because it's a Snowflake schema, and that's how it has been built. And a lot of KPIs inside has been written. Computed logic, computed definitions has been built. Okay. Now what we did here is in order to solve the problem. So again, as I said, the problem is the KPIs and insights, and these KPIs and insight are needed. Okay, so we cannot rewrite them. We need to use AI. Need to use them. So AI need to cannot go and create new KPIs and insights. So these existing KPIs and insights, which are very well defined on their business side, has to be reused. Okay, by the AI. So what we did, first of all, ETL, we kind of moved to a Azure Data Factory because it's serverless, provided real-time changes as well. Again, the same structure we followed, converted into Delta Lake on the blob storage. We did the Spark streaming here, and we use the Delta Lakes on the Azure. So Databricks provide both the option on the Azure, also on the AWS. So this version we used. Now, in order to solve the problem, we use another tool which call as the at scale, and this is primarily for the semantic layer. Now, what the semantic layer is? Semantic layer is primarily a way of building your own business logic, your own business definition as far as analytics is concerned. So, if you have analytical data and you want your business team to work on it, so if you have worked on a Tableau, you can very easily visualize this. The way the Tableau works, it connect to a data set. Then you can clearly see dimension facts. Then you can select couple of dimension and facts, and then it allow you to choose a visualization. So there is a certain level of magic is there. So same magic happens at scale as well, or the semantic layer. The primary purpose of the semantic layer is to reduce the uh, naming convention duplication. So for one of the example, let's say, is the balance. Okay, so balance for one department could be named as balance. For some other department, it could be user balance. And the way it has been calculated might be different for different departments, different user, different tenants. Okay, so it's not standardized. So if need to be standardized, this is what we are calling as a semantic layer. And the introduction of the semantic layer on the top of the your delta lake actually solve this problem. So what will happen using the semantic layer? Your business analytics folks can go and define their KPIs inside the tool. So they don't need to connect to Databricks, or they don't need to write any code or store procedures to define their KPIs inside. Just like a normal Tableau kind of tool, they can see, they can discover the data, they can see the schema, they can select the multiple facts, dimensions, they can explore multiple contexts. And once those fact tables are explored, selected, essentially you can build your KPIs, insights, you can write business logic on it. And all this creation of KPIs and insights are semantically uh, unique. Okay, so once you define a business, everywhere business will be used. So there will no more user business or any other business as well, any other balance as well. So this is the one case. What it took like 1.5 years for us to migrate everything over there. They are still using SQL Server as their OLTP, but they have replaced their data warehouse completely to Azure Delta Lake on Azure, on semantic layer on top of it. One of the important thing for the semantic layer, where the moment we implemented the semantic layer and then we started building our RAG pipelines and building our AI responses, uh, the output was golden. Okay, it was completely gold, because this semantic layer reduces all the redundancies as far as business definitions are concerned. So there were no duplication. AI, for AI, the definition is this, the data is this, is properly defined, it is completely clean, and with the combination of well-defined Unity catalog, this work like a magic. Okay, so still there were issues, but for the AI, this semantic layer and the combination of Unity catalog works very well. So scalability, now we talk about a lot of enterprises, large scale systems. Now we will talk about very simple startup. So this is a Series A supply chain startup handling 200K orders per day. So pretty decent. So they are getting their growth journey started. They don't have any data strategy till now. So they want to build a centralized system, but essentially their request is three. So they want three things. Number one thing, they want a solution which can provide analytics, KPI insights. Second is it should support a text to SQL so that AI-based queries can be delivered, responses can be seen, included the data itself. Third part is need to be cost effective. So you cannot have Spark instances, large Spark instances running there. Okay, so this is the architecture they had earlier. So this is they have microservices, Java based microservices, MySQL in the RDS in the AWS as a primary source, Redis, Elasticsearch. And what they did is using the Tableau, they built the SQLs, a lot of SQLs they built, and using those SQLs, they build their analytics. Okay, so the whatever the analytics they had, they did using that only. So what we did for them, since these three requirements are there, we went ahead with our classical structure like Debezium, CDC, Kafka, Delta Lake, Spark Streaming, Databricks, and the GenAI. So two things here. In order to, as I said, there are three problems. So number one problem was the analytics. So using the Delta Lake, we built the gold layers for them, which essentially became the source of truth for the Tableau reports. So this is the one problem get solved. Second problem, the text to SQL. We use inbuilt tool called Jenny. So it provides text to SQL. So essentially, what it allows you to do that, you can select a context, you can write a human natural query, human very natural language like top two orders in last 3 days kind of thing, and it will generate an SQL behind the scene. It will execute that SQL, and then whatever the data will come, it will give you the data or it will give you the visualization. So these things is already done at their end. We just kind of used it and provided the text to SQL. The last part is the cost-effective solution. So one of the thing which we evaluated, did the POCs, did the benchmark is Databricks provides a way to run all this on the serverless. So let's say Tableau, one of the Tableau dashboard need to build, and it consumes like 100K data. Okay, pretty decent data, and these 100K data need to be fetched. So normally in the traditional way, what happens is Spark instances need to be keep on running. Your Delta tables need to be keep on running. But in this case, what we did, we built Delta lakes completely on S3. So all the tables in the bronze, silver, and gold were completely external tables, and they were consumed inside the serverless instances. So this is something for the cost optimization. We thought Databricks might be costly, but just because it was providing the serverless, it solved our problem. So please check out these two things. This is what I learned. GenAI as a product is very beautiful. People complained a lot that sometimes text to SQL don't work, but this is an exception. Last part is I will talk about the context. As I said, it's a very important piece of it. If you build your data properly, it will allow you to have less hallucination, very uh, so if you don't do it, you if you directly connect to your database and try to do the RAG or chunking or semantic search, what will happen, right? So you can get the hallucination, you can get the wrong information. Trust was won't be there. Okay. Uh, Another thing is next set of questions will be misinterpreted. So something might come. So what need to be done? First of all, you need to use a technology which implicitly provides the access control. This is the first important part. So traditional data warehouses like Redis or SQL servers or Oracle don't provide the access control implicitly. And without the access control, it is very hard to build the context. Uh, Again, you need to use the vector databases like Pinecode or PG vector. And here is the thing, then chunking is there. You need to have your metadata catalogs there. For the hybrid search, for re-ranking, you need to reprioritize those. Then you need to store your embedding, you need to build the real-time pipeline so that all these embeddings can be updated with the real-time changes. And if you do all these things, vector, metadata, ranking, and the real-time updation, essentially you will get a reliable, context-aware system. The very last case study is relevant for the context, and it's a healthcare SaaS startup which is managing multiple hospitals, around 50 hospitals, ingesting 2 TB of data per day. They want GenAI to run the natural language queries over all these patient data. Okay, so their current architecture is like typical microservices Java, Oracle and MongoDB, Redis, and what they did essentially is they built They use Hadoop because it's a lot of data for historical analysis. Tableau as a BI dashboard. What we did here is we repeat the same architecture. We introduce RAG here. After the Unity catalog, the change you can see that we use the vector DB, primarily Pinecone here. And Databricks also provide some GenAI tools which you can use in order to build your RAG. So this is one another last example from my side. Uh, so before for going into the QA session, what I like everyone as an audience, and this is something I do with every new project for myself, that I check all these 7 things, whether data is centralized, unified, can be discovered using catalogs, whether the quality and reliability checkpoints are implicitly defined. Again, as I said, implicitly, not explicit. Can it support the real-time prompting, real-time responses? Can the data can be trusted enough? Is there a way immutability or the important transactional data audit has been saved? Again, as I said, it has to be cost effective. You need to very clearly define whether it's a premium product or if it is not, then a lot of cost optimization you need to do. And context you need to build very upfront as a part of your design first approach, that okay, I will go and define my context, because in a normal enterprise there is a hierarchy of data, and if you don't define the hierarchy, don't define the context, and if you don't define the context, then there are problems.
Wow,
So
Radner, thank you so much. That was great. It was so much depth and in those examples, and I think everybody left with a real sense of what the biggest challenges are with data readiness. So I appreciate all that. So I think it's time for our question and answer session. So to our audience out there, if you haven't submitted your question yet, there's still time, but please do it now. So there's that Q&A button at the bottom. You can type things in there, and we'll try to get through as many as we can in the time we have remaining. But let's start off with a couple of initial questions. All right, so here's mine. So Renish, what's the number one red flag? The blinking warning light that indicates that your enterprise may not be ready for AI, or your data may not be ready for AI to be more.
so number one flag, in my opinion, is is the quality. And if normally what we do, if we have to do a very simple POC, we ask organizations to define a golden standard of data, and this is where a majority of things get haywired, and people has to work on this part. And even after this part is done, once you expose your data warehouse to AI, uh, you don't know what's going to happen, what kind of data it will access, what kind of data it will run onto, what kind of hallucination or false positive it will create. So it's very hard to control. So you need to have a system where implicitly there are ways to define the quality checks. So quality is, I will say, is a number one red flag.
Okay, cool. So if someone out there wants to get started, what do you think the very first step? What's the very first thing they should do?
I think if you are starting your AI journey, so I will construct the whole thing like this. If you have data strategy in place, like if you have an existing data warehouse or existing data lake or data pipelines are built, uh, you need to make some design changes in the system. So essentially, you cannot go and tell your stakeholder that yeah, yes, we have a data warehouse and we can build RAG on top of it. So it's not the way to go. I mean, you need to understand what is the RAG's requirements are, how the data will be saved, how the embeddings will be saved, how the chunking need to be done, and the last part is the cost effectiveness. How you will reduce the cost, because you can definitely add new tools and technologies, but again, those going to be costly enough. So I think this is the first step if you already have the data warehouse in place. Next part, if you don't have, then life might be easier. Uh, you can build the system more straightforward. The way to go right now is you need to define your AI use cases. Once you know your UI use cases, you need to look for the data. What kind of data this all will be required. Then you need to just go through the 7 checkpoints, because this is something I kind of we kind of extracted it out for you. Yeah.
Right. Okay. So you mentioned a lot of good tools, and you've implemented systems using Databricks and vector databases and real-time pipelines. So what kind of factors drive the choice of which specific tools you use in the context of data readiness? So we've got a lot of tools we can choose from, right?
So for example, if you want to build the Delta Lake, you can use open source as well. You can build the whole Delta Lake in the Kubernetes itself. That we did also, and you can also build the whole thing on the Databricks. Now you need to benchmark and check the cost. So most of the time we think that Databricks might be costlier, but it provides a lot of convenience for you. Its pipelines, deployment pipelines are very smooth, and they have invested heavily on the AI side in last 2 3 years. So if you're not sure where to start, I will simply say go with the Databricks, and later on you can move to open source and Kubernetes. So yeah, this is the answer I would say.
Okay, great. So let's talk about how do you strike a balance between rapid experimentation and data governance, right? Which takes a little longer, is a little more measured. So you want to get things up going quickly and kind of see what you're working with, but you also have this governance question, which is obviously of utmost importance. So especially because things are moving so fast in Gen AI. So how do we balance those two things?
So for this purpose, a couple of tools I would recommend. One of the tool we use as a DBT, we call as a DBT, and that is a model definer tool. So essentially, what it will allow you to do is, as I said earlier, Unity catalog and data governance is important, but fast prototyping is also important. We cannot wait for someone to complete the data governance and then we will go and build our POCs, right? So DBT is one of the tool you can use which allow you to do fast prototyping as well, and you can very quickly do the schema evaluations, and also you can build the whole data governance Unity catalog over there. Another tool which we are kind of at the very fast prototyping we are recommending is the DLTs. So DLTs are the part of Databricks itself, and using these live tables, your business people or also you can write very smooth code which can run on real time without any deployments and all, and this will keep on updating. So it's not like an external table where you have to run a job in order to update that external table. It will be automatically updated the moment your data will get the next set of events. These tables will get automatically updated. So for fast prototyping and maintaining the data governance, this is something you can use.
Okay, great. So Talentica works with many industries and from financial services to SaaS. So have you observed in your experience any differences in how different organizations in different industries approach data readiness? And if there, first, let's talk about the differences, and then maybe talk about any surprising patterns of similarity.
So one of the thing which we are seeing with the SaaS software, so they are kind of looking to integrate AI in their system. They want to build agentic systems. They think that AI agents are something which can disrupt their businesses, and this is the talk of the town right now. What essentially they are asking is, in their SaaS platform, is there a way these AI agents can be integrated? MCP servers existing can be reused, or either they can build the MCP servers, can do the licensing top of it. So one of the thing for the SaaS is at the end they are software running on a hardware, and essentially that's all they are selling, right? With the AI agent, this concept itself is getting disrupted, and what they are looking for now is a plugin structure where agents can pop up and talk to their MCP servers. They can charge on top of it. So a lot of things are happening on that space itself, on the business, also on the technology. Primarily on the fintech, they are little slow to adopting the AIs. And as I said earlier, still AI is non-deterministic. AI data is, if it is not very well defined, curated catalog, then this might be get exponentially, you will get exponential hallucinated and false positive. So now the fintechs are, first of all, they are very hesitant to use the AI itself. Second is, even if they somehow get ready to use the AI, they are very spectacle about their data uses, because they have regulators on top of their head, and regulator has very strict way the data, wherever the data goes, it cannot be replicated. So now if you generate the embedding, it's a kind of replication of data. If you don't generate the embedding, it's very difficult to run your RAG. Very difficult for you to do the semantic search, right? But embedding is again is one kind of replication of data. So again, for the PCI compliance, it will create problems. But the encouraging part is, since they are seeing the value of it on the recommendation deals, all those kind of systems, they are looking for us to kind of solve these problems, making sure that security is there in place, PCI is not disrupted, uh, data is do replicated, but doesn't violate the regulators' policies. So fintechs are going slow, but going carefully. Yeah.
Okay, excellent. Well, that was great. I think we want to respect people's time. We're reaching close to the end of the hour here, so I think we're going to wrap up for today. So thank you to everybody who attended the webinar. Hopefully, you'll find out if your data is ready for AI. Big thank you to Ratnesh Bahar from Talentica Software. Thank you so much, Ratnesh, for sharing your expertise with us today. And
Yeah.
thanks to all of you for joining us. So as a follow-up, just want to make sure you guys remember you will be receiving the slides. You'll receive a replay link, as well as our poll results directly into the inbox of your email that you use to register. We'll also be sharing a list, and a little extra here, of all the tools for AI that Talentica referenced in our use case examples today. We'll also include some details on how to connect with us if you'd like to take a deeper dive into your organization's data readiness. So thanks again, everybody, for joining us, and we look forward to seeing you again at our next session. Thanks a lot. Bye-bye. Have a great day.
Thank you, Mike, for hosting this.